I've created an interface called ToyBot, and we'll add some code. It turns out an interface is just a special type of abstract class. Now, we actually write public interface. Instead of saying public class, we say public interface. And I'm going to say public interface ToyBot. All right, that compiles just fine. Now, like I said, an interface is really just a special type of abstract class. In fact, we call it a pure abstract class. And you'll see why we use that language in a little bit. Now, when we write a class, we usually think of three things. We think of constructors, instance variables, and methods. All right, so let's try to write a constructor for ToyBot. So public ToyBot, I'll just make it a parameterless default type constructor. But when I hit compile, it doesn't like my constructor. And I don't see any spelling mistakes or anything. Yeah, this is actually it's going to be a rule with interfaces. Okay, this is like rule number 1 for today. No constructors allowed. All right, so no constructors allowed when you're writing an interface. Now that's getting back to that pure abstract of it. Remember the other day when we learned with an abstract class, you've prevented anyone from making objects from it. So this is a pure abstract class. Nobody can make an object from it, and we just take it away right here. There's no constructor even, okay, for this class. Now, like I said, constructors, state variables, methods. Okay, let's try out a state variable. So a lot of times we like to put in state. So this ToyBot, maybe it has a private double price. Okay, and I want to declare that private double. Well, this is kind of a strange error message. It says equals expected. I don't know that we've ever seen that error message before, but apparently it wants me to put an equal sign into my declaration. I can't just declare it. I've got to initialize it, and I'm going to make it $9.99. Okay, my ToyBot costs $9.99. Now it says modifier private not allowed here. Oh, let's get rid of it. See if that makes it happy. All right, now we're compiling. So, okay, here's the truth about state variables or any variables within an interface. This is a default setting for all interface variables. Okay, so default setting, all interface variables are public static final. Now, when I say default setting and I say all, what I'm saying is those keywords are put there for you, even if you don't put them there. So if I wanted to, I could put right here public static final double price. Okay, that's allowed. But even if I don't put any of those words there, as far as the compiler is concerned, they're there. So that's why I couldn't put the word private there. That's also why it demanded an equal sign, is because this, like I said, this is a final. Remember what it means to be final? It means you can't change it. So if I want to change my mind and make the price $10.99, I can't do it. Okay? Price is a final variable. I can't change it. Now, the fact that it's static, that's going to give me different ways to reference it in the future. And it also means that all ToyBots are going to share this variable. All right? So apparently all ToyBots are going to cost $9.99. All right. And so if I made another variable, like, if I put in a string or something, it'd be the same rules. So all interface variables are public static final even if you don't write those words in front. And you can't change it. You can't make it public. You can't take away that aspect of it being final or static or any of those things. Okay, so no constructors. I mean, it's not even really a variable at this point. It's a constant, but all variables are treated as public, static, final. Okay, and now let's look at methods, the third piece. So let's say that I want to make a method that returns a string. I'm going to call it the speak method. And I'm going to put in instructions in here for what to say. So I'll say return, I am a toy bot. All right. So remember now, we tried to put a constructor in, it wouldn't let us. We tried to put in a state variable. It let us after some modifications. What about our method? Well, all right. Interface abstract methods cannot have a body. Yeah, now that's kind of weird. Like, I didn't say that it's an abstract method. Now, if you forgot what an abstract method is, remember in the student class a couple days ago, we put an abstract method in. And when we did that, we had to remove the body from the method, and we had to end it with a semicolon. Like, that was a rule. And I'm kind of seeing that same thing here. It's saying, okay, interface abstract methods cannot have a body. The difference is, today, I didn't write the word abstract. But this is like with the variable. I essentially did write that word. Once I make a method in an interface, I'm making an abstract method whether I like it or not. So this is like another default setting, okay? When you're working inside of an interface, all interface methods are public and static, okay? And you don't get to change that. So I could write public abstract string speak like I did. That's fine. But I'll just tell you, like, that's not the industry standard. So, like, if you were writing an interface for a job or something and you did that, your boss would probably laugh at you, like, oh, he doesn't know what he's doing. So, typically, you would just write string speak because it's already been implied that it is public and static. So, for you to say it again is just like being redundant. So you don't really need to say public and static in front of it. You just say string speak. I know that looks a little weird because usually every time we declare a method, we always say if it's public or private, whatever. But here, you really just list the return type, the method name, and the parameter setting. So if I wanted to make like a void method called walk that accepts an integer number of steps, I could do that, and this is how I would write that method. I would just say void, that's the return, okay, the name of the method and any parameters, and then I would end it with a semicolon, and that's it. Now, can I put the words public and stat? I did it again. I can't. I did that last period too. I'm so mad at myself. All right, I meant to say abstract. I don't know why I did that. I did that 2 classes in a row. I'm sorry. Erase static from your brain. All right. The variable is static. The method is abstract. I'm sorry. All right. If I wanted to, I could put abstract in front, public abstract void walk. Okay. But as I was saying, that's not like the industry standard. Normally we would just say void walk because it's already a given, right? Remember, it's default. It happens with or without our consent. That's what it's going to do. All right? So this is our interface. It's what we call a pure abstract class. No constructors allowed. You can't put one in. It's an immediate compile error. All right? Variables have to be public static final, and they are public static final whether you say so or not. If you try to change it to private, can't do it. If you try to change the value, can't do it. And methods are automatically set to public and abstract. And a consequence of them being abstract is that you cannot give them a body, right? You have to just simply end their method declaration with a semicolon. That's it, okay? Now, another consequence of this is anything that's beneath this interface is going to be forced to implement these methods. So you might remember that with the student class the other day. Once I made this method abstract, I forced all subclasses to have a greeting method. So like in my elementary student, if I didn't have a greeting method, I couldn't compile anymore. Okay, so the same thing's going to happen today. Now we use like different language. With a superclass subclass, we say that you inherit the class, and the keyword we use is extends. Okay, we use a little bit different language with an interface. With an interface, we say that you realize the interface. So I'm going to make a spider bot now, and my spider bot is going to realize this interface. So public class spiderbot. If I just stopped right there, it would compile fine. Okay? No big deal. There's no like real link between these things yet. But what I'm going to do is I'm going to now write after the word spiderbot implements toybot. So I know it's weird. Like I say that you inherit a superclass, but the keyword is extends. We say that you realize an interface, but the keyword is implements. Don't blame me. I didn't come up with this system, but that's the language used. Okay. So we implement toybot. Now watch what happens. I won't be able to compile anymore. Okay. How come I can't compile anymore? Once that arrow got drawn, and this link was created, okay, abstract methods have to be overridden. Same thing here today. Okay, just like from the abstract class to the subclass. Now, before I can compile, I've got to complete that walk method, and I have to complete that speak method. So remember where we last saw the speak method? It looked like this, string speak, okay? And in here, originally it was going to say return I am a toy bot. Today this time I'll say I am a spider bot. All right, and I'm going to have to put in the walk method too. So the last time we saw it, it said void walk int steps. I'll just put st here for short. Now that's a void method, so I don't have to return anything, and I'm just going to leave it blank for now. All right, I'm going to get kind of a weird compile error. I don't know that I've ever talked about this with you before. We've talked about public and private settings before. If you don't specify public or private, then by default your class or your method or your variable, whatever, is set to protected status. And I don't think we've talked about protected. It's not tested on the AP test, so I probably never mentioned it. Okay? But apparently it doesn't like us trying to make this method protected. So we have to spell it out. We have to say public. So a little weird. Remember in the interface, I didn't actually specify public in the toybot interface. Like I was saying, the industry standard is you wouldn't write public or abstract there. It's just kind of a given. All right, but apparently I have to write public on the override side, because if I don't, it tries to make it a protected method, and it doesn't like that. It doesn't like me going from public to protected. The same exact thing would happen if I tried to make one of these methods private. It won't. See, it doesn't like that. It's what they call weaker access. So I guess, once it's declared as public in the interface, even though I didn't say that, it has to be public when I realize it in the override. All right, now in this class, there aren't all these rules now. We can do all kinds of things in here, okay? So in this class, if I want to have a constructor for a spider bot, I can. I could even put in like a state variable, so I could say like private string name, and then in here maybe I'll accept a string parameter, and I'll use it to initialize the name. So all of this stuff's good, okay? And, you know, I know we couldn't do that in the interface, but now that we've realized the interface, this is just a regular class. We can give it a variable. We can give it a constructor. We can give it its own method. I could say public void make web. All right. Now I don't know what that method's going to do, so I'll just leave it blank. But I can do that now. Okay. Toybots don't have to make webs. Toybots only have to speak and walk. Right? Since those methods were in the interface, that's basically then like a guarantee that every Toybot will be able to speak and walk. All right? That's my promise to you. If you buy one of my Toybots, it will speak and it will walk. I promise. But only the SpiderBot can make a web. Okay? All right, so this is my SpiderBot class. Now, maybe you're wondering, like, why do we have an interface? It's kind of like an abstract class, so why not just make it abstract, and then you can give it a constructor and a variable, and you get some more freedom, right? An interface is basically an abstract class with a bunch of extra rules. So why even have an interface? Well, the one kind of big structural advantage is when you have an abstract class or any type of superclass, you can only inherit one class. That's it. Okay, so you can only inherit one class. You can realize as many interfaces as you want. So if I had more interfaces, I could just put a comma here and start listing additional interfaces. You could realize 10, 20, 30 interfaces, whatever. Okay? But you can only extend one single class. All right, now that might not seem like a big advantage to you, but that is an advantage. All right, let's make, real quickly, let's make a T-Rex bot. A lot of kids like dinosaurs, so, all right. Now, when I make this T-Rex bot, I'm going to be required, remember, to give it those two methods. So I'll say public class T-Rex bot. And again, I'm going to say implements toybot. Now, once I put that word implements there, I'm forced to override those two methods. So I went ahead and copied them. And I'm just going to change it real quickly to say that it's a T-Rex bot. And just for the sake of time, I'm not going to give this one its own constructor or state variable. Oh, I copied the wrong methods. That was smart. Let's try this again. I wanted the walk method, not the make web. I don't think T-Rex could make a web, could it? I don't think so. All right. We could put like a shake tree method or something. I don't know. Yeah. Isn't that what it did? Yeah, that's true. All right. So, okay, I think this is fine now. All right. So we had to have a walk method and a speak method. So, okay, we got our T-Rex bot. All right, I'm going to copy all of this. I'm going to make one more, and then we'll move on to something a little different. Let's make a rhino bot. I can't spell rhinoceros off the top of my head, so. All right, so this is a rhino bot, and if you ask it to speak, it will tell you that it's a rhino bot. All right, so everything looks good here. Our interface looks good. It's communicating with all of these classes. Okay? Notice that the three classes, Spider, T-Rex, and Rhino, they're not linked together like directly, but they're all realizing that interface. All right, let's look at the implementation side. Let's look at the tester class. So we're going to write here an interface tester, and this is where we're going to house our main method. Okay, so this exists off, to the side here. This is something else. So we're not going to implement ToyBot here. This is where we're going to put our main method. So we got public class interface tester. Got our main method. Well, as you might imagine, if I tried to make a ToyBot using the ToyBot constructor, remember, we were prevented from making a constructor. Okay, so this shouldn't work. And it doesn't, all right? And it says ToyBot is abstract. You can't instantiate objects from an abstract class. So again, even though we didn't write the word abstract in here, like we did with our student class, an interface is a pure abstract class. An interface is basically an abstract class with additional rules. So that's what we're seeing. So you can't make an object from it. All right, so this won't work. This is illegal. Okay. Now, what I can do though is I can still have like a ToyBot pointer, okay, and I'll use that pointer reference to construct maybe a Rhino bot. Now, if you remember, the Rhino bot class didn't have a constructor, right? There was no constructor in the Rhino bot class. So remember, if you don't provide a constructor of any type, Java writes one for you. And that's what's happening here. So it's using that Java created constructor to create a Rhino bot object. And now we see, same type of thing here. I know for a fact that there's two methods in here that I can reach through toy2. Okay? And those two methods I know of are the speak method and the walk method. Now the walk method is void, so I can't call it from within a print statement. But both of these method calls should compile without error. Oh, I got to give it a number of steps. Sorry. Okay? And so they both compile. Now, again, I know sometimes it's confusing, like why on earth would we want an interface? An interface can almost be like a table of contents. If you had like a really big program, you might have 50, 60, 70 methods in that program. And the program itself might be 3,000 or 4,000 lines of code, maybe more. Well, your interface would be like a table of contents. Like you would have listed there those methods, and then all of a sudden somebody can just look at that and go, oh, okay, I know that it's got this, 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 and this, all from these signatures, and then they know what they can do with that object real easily. And then it also kind of creates like this common functionality. So all of my bots are guaranteed to be able to walk and talk, right? I know that. Every single one of them is going to have those two methods. They can't exist without it. All right, so this looks good here, all right? Now, I could also do this. I could say, for example, SpiderBot toy3 is a new SpiderBot. So I don't have to call it a ToyBot on the left. The advantage is by calling it a ToyBot on the left, I can change my mind later and point it to one of those other subclasses. Now, this is not going to work, and I bring this up because a lot of people missed this on the quiz. The Rhino bot had a default constructor because we didn't put anything in there. Java created one for us. as soon as you put a constructor in, Java figures you don't need them anymore. So in the SpiderBot class, we put a constructor in that expects a string. And when we do that, we're basically saying, like, SpiderBots have names, you better tell us the name. And so now Java will not create a default constructor for us. So if I tried to compile this, it won't work. I've got to put a name in there for this spider. Okay? So if I don't give the spider a name, I can't create it. So that is kind of strange. I know that, we didn't write a constructor for RhinoBot, we were okay. We didn't write one here either. The difference is, I'm sorry, we did write one for SpiderBot. Now we have to use it. All right. Okay, so I wanted to point that out because that was missed quite a bit on the quiz. Now, again, if I took from here these two methods and did toy3 speak, toy3 walk, this would be fine. Okay? And in addition, toy3 has the ability to make a web. All right? So there we go. Now, see these two speak methods? This is our polymorphism. So if I run this right now, we're going to see two different results. So we've got the same method, different implementation, leading to two different results. All right, so again, that's polymorphism, just like we saw previously with the super and subclasses, inheritance. How does it know what to say? Well, RhinoBot constructor said it was a RhinoBot. Okay, SpiderBot constructor said it was a SpiderBot. And the same thing should happen with T-Rex. And it didn't matter what was on the left, right? It never said I am a toybot. In fact, that was impossible. If you remember, when I first wrote the speak method, I tried to make it say I am a toybot. It wouldn't even let me. So there was no way it was going to come up to here to execute a method. Okay, it had to run it from the RhinoBot side. So it should be a little less confusion here. Now, I could get in some trouble like this. If I made this SpiderBot a toybot, so watch what happens now. Okay, it can't find the make web method any longer. It found the speak method and the walk method just fine. Why didn't it find the make web method? Well, remember, whatever's on the left, that's what you're pointing to. So that points toy3 back to the interface. Is there a make web method here? No, not all of the bots make webs, but the SpiderBot does. So you have a couple of choices, okay? What I had previously worked. Remember what I had here previously? SpiderBot? That worked. That pointed it to the proper class. What's the other thing I could do if it is a toybot? I could downcast it. I could downcast it temporarily and point it to the SpiderBot class, and I would still get there, okay? So just like we saw with superclasses and subclasses, you can still downcast, okay, through an interface, perfectly okay. All right, the one last thing I want to show you is just, remember we had that public static final variable cost? So there's a lot of different ways that we could access cost right now. For example, I could say system out print, and I could use toy2 as a path to the cost variable. Or was it price? Was it, oh, price, sorry. Okay, so I could use this as a path to the price variable. All right. I could also come here and do toy3. Now, since it's a static variable, I could also call it directly from its class. All of these should say $9.99. And not only that, since it's public, it's inherited. I should be able to reach it through SpiderBot, T-RexBot, and RhinoBot. Now, we never even created a T-RexBot object, but it shouldn't matter. It should still get there, Okay? That variable exists and it's accessible. I never even used the T-Rex bot constructor in this main method, but I can still reach the variable this way. So all of those should print 999. Let's just check it out real quick. Okay, yeah, they all say 999. And also remember, that was a final variable. So if I took this and I said, you know, I'm changing my mind, I want to make it $12.99, I can't do it. If this variable wasn't final, I could do that. I could remotely change the price of a public variable this way. But since it's final, I can't. All right, so this is illegal here. Okay? All right, a lot of stuff we just went over there. Any questions?